Seems like it's working
Uh-huh.
off of the hotspot. Okay, my phone's. Wait, you can't see it.
Yep. Awesome. So,
Ouch, here is like too low.
uh, wait, what was that?
I like had my phone here and you couldn't see it because the couch is too.
Got it.
Okay.
So, yep. What's new?
I had this craziness. It was raining really hard here yesterday. I don't know if it was the same by you.
Yep. Yep. Yep.
So I don't know. My like power wasn't working in the morning and then
Mhm.
so I was just dealing with a bunch of stuff. But I was trying to go over the that sheet that you sent me with the different equations, the site.
Okay.
So I was working on those and then we have a few of the Jack Westin left to go over. We're on like 78 out of like 100.
Yeah. Which site are you talking about?
You sent me, what's it called? IntegratedMCAT.com, the physics cards.
Oh, yeah. Yeah. There are those. But for the equations, I would do
The
that.
essential equations sheet, yeah.
The
And the Anki deck. I set up the essential equations Anki with you yesterday, so I started going through it today.
got it. So, all right. Yep. We can continue.
Okay, all right. Um, yeah, so this one.
So, sound, since it depends on a medium, will travel faster the denser that medium is.
Okay, I guess that makes sense. I would assume that like water's the slowest.
Okay.
And then I like between warm air and cold air, I was thinking like particles, like
Well,
how
now that you know that the denser it is, the
so
faster.
wouldn't it be the opposite? Would it faster travel faster through cold air?
What? So what about water? Like how fast would it travel through water?
I guess quicker.
So I mean,
That doesn't make sense, like with like what I'm thinking about. Like water is a dense thing, right? Like,
I mean compared, so like steel is a solid,
right.
and so water,
So solid, liquid, and then gas would be the slowest.
yeah, yeah,
Like air.
yeah.
Okay.
And then between warm air and cold air, right? What's the difference there?
Well, cold air is more packed.
Good. So more dense, right?
Yes.
So warm air should be the slowest.
Yes.
Good.
Okay, makes sense.
Mhm. Okay.
This is for sure, yes.
You said a guess?
Yeah.
All right. So walk me through what we can do here.
Okay. My God. Okay. I'm sorting. Oh yeah, it's right here. Okay. So we know the lapse. That's time.
Okay.
We know speed, meters per second. Isn't that velocity?
Yep.
Okay.
Mhm.
How deep?
Yeah.
Um, equals, is it, what's the equation when it's velocity is equal to, is it density over time?
Density.
Density, distance.
Uh-huh.
Okay, so V equals D over T. So 0.1 times 1500 would
Okay.
give, yeah, would give us D.
What? Wait, what?
The distance.
Oh, sorry, I thought you meant answer choice D. Good, okay.
No.
So,
That's 150 meters.
okay.
Am I missing something? How does it get to 75?
Um, so in the question stem, that time lapse is between what?
Sending and receiving the sound pulse.
Yep. So what you calculated is just the sending portion. Or rather, so you're sending it and then it bounces back and you're receiving it.
Uh-huh.
So if the time between sending it and receiving it is 0.1 seconds,
Mm-hmm.
right? That time includes both sending and receiving, which is double the distance.
Oh,
Yep.
I get it. So it has to be half of 150, which is 75.
Yep.
Okay, that makes sense.
Yeah. Yeah. 50% shows 150. But
150.
that's why I always say, like, like again, like,
Read carefully.
well, yeah, but also pre-meds, they're used to taking like in pre-med physics, like they just have you like hold the calculator and you're just looking at like, okay, what do I plug in and stuff. But on the MCAT, it won't, like there would be some additional thing that would force you to have to understand it conceptually. Because if you just use the formula and you plug stuff in here, you'd get just the 150, but the 75 you would get from actually understanding it.
Okay, got it.
Yeah.
I think I literally just said
Uh-huh.
what it says here.
Okay. But like, you know, do you know?
Okay, let's think about it.
Yep.
Oh, I know how I got this. I didn't use the speed of a sound. I knew that it had to be greater than 300 because it's moving towards
Mhm.
like the observer. So they would like be more than just the frequency that from where it is.
Got it.
I'm thinking like as ambulance approaches you, it gets louder and louder. So that's how I got the 340. I didn't do any calculation. I just like knew
Uh-huh.
that it had to be greater than the sound that it releases.
So you said louder, but um, what is like the actual
The
thing?
frequency of the sound.
Yep. So that's like pitch.
Yeah.
Yep. Good.
Okay. So higher would be the word, right? Not louder. Okay.
Oh, just like higher frequency.
Mhm. Okay.
Okay. So like resonance, harmonics and stuff.
Uh-huh.
Um, you're like somewhat familiar with that, I guess, right?
I think so. Mm.
Yeah. So there's basically two types. There's like what we call even, which could be like open, open, or closed, closed. And then we can have odd, which will be like open, close, or closed, open.
Uh-huh.
And just, I guess, the fastest way to like, because the fastest way to just, I guess, go over this would just be to kind of tell you the equation for something like this. So, like, for the even, it will be like, well, the frequency will be um NV over 2L. So the N is going to be representing like, well, you can have like, and if it's N is equal to 1, it'll be the fundamental frequency, but you could have like, the first or, the second harmonic, um, and stuff, which would be like n is equal to 2.
Mm-hmm.
So, n could equal 1, 2, 3, pretty much any number. But for odd, which is when it's open, closed, or closed, open, it will be NV over 4L. But n could only be odd numbers. So like 1, 3, 5.
Mm-hmm.
So, okay, so now this question stem is saying a sound is produced near the open end of a pipe, which is closed at the other end.
It has to be odd.
Yep.
So 4L length.
Well,
So
this formula here, but
frequency equals.
and they say that the length of the pipe is 50 centimeters. So
Uh-huh.
I would just write that as 0.5 meters,
Yeah. And
which,
then you multiply that by 4, right? Because length is in the denominator. So you get 2 meters.
and then the lowest resonant frequency is 170 hertz. So like the fundamental frequency F1 is 170 hertz, right?
Okay, so 170 hertz is equal to V over 4 times 0.5 meters. So 2 meters.
Sorry, what are you, sorry, say that again?
Like, do you solve out to find the V since NV, right? You have the lowest frequency. You know that N is 1 in this situation. So that way you have all the values and then you can solve for the largest resonant frequency.
Okay. So,
Is that the wrong way to?
yeah. You could do it that way.
Okay. So it's 170 equals V over 2 meters. 2 times 170. $340. And then,
All right. So tell me what you're doing exactly.
oh, I guess we can't do that because we're not going to know what the N is later for the highest one.
Wait. So okay, tell me what you just did.
I think I just solved for V.
All right, and tell me how you did that.
I plugged in F1. So I took I made N be 1. I made F 170. So 170 hertz is equal to V over 4L. Length we had 0.5. So times 4, that was 2 meters.
Okay.
So then I multiplied 170 by 2 and got 340. And that was V.
Yeah. So 340 is the V here, and now what?
Well, now I'm confused. Do you just plug in the next largest? So that would be N is 2.
Uh-huh.
Okay. So 2 times 340 over 2. So it's just, you right?
Yeah. Okay.
Oh, it's odd. It can't be 2. It has to be 3.
Oh yeah. That's good catch there. Yep. Good job.
So 1020 and then divided by 2. Then you get 510.
Perfect job.
Was that the way to go about it?
Yeah, that was perfect. I couldn't have done it
'Cause
better.
you were like, when I started doing it, you threw me off because you were like, well, that's one way to do it.
Oh yeah. I wasn't sure what you're doing at first, but yep,
Oh, okay. All right.
great stuff.
Sounds good. Um, so Honestly, I wasn't sure. I kind of just like went with like what I know about mirrors.
Mhm. Um, yeah,
Isn't convex the ones that face inwards and concave or go outwards? So I knew B was wrong.
think of the word cave. It's like a
In
open,
yeah, cave.
also like a cavity opening.
Uh-huh. Yeah.
So would this look like something that goes inwards? Or
No,
would,
that's just outwards.
yep.
That's yeah, convex.
So this is concave.
Yeah. No, this is convex. This is concave.
So cave means, you know,
Ow.
like you can there's like an opening inside.
Uh-huh.
So that's kind of closer to this shape. See how it goes, how it's like an opening in the center, right?
Okay, yeah.
So this is concave and then this is convex. Convex points out like curves outwards, whereas concave curves inwards. If you imagine your tooth like this, a cavity would be like something like that, right?
Because I always thought like concave caves are inside, so it goes inwards.
That's exactly what you see in this shape, though,
Yeah, okay.
right?
Okay,
Goes outwards, right?
okay.
You have a standard which is just straight, and then you go outwards, and then you go inwards, right?
Yes.
So yet another instance of, figuring out from like the word.
And then converging light is like when it like goes into one from like two light sources. So that's different
Yeah, so I mean, not from two light sources, but
from
uh
two angles.
yeah, so a convex lens would be converging, it converges like this.
Uh-huh.
A concave lens will be diverging, but for mirrors, it's just the opposite.
Okay.
So, um,
A plane, doesn't it go off like of a plane? So it hits it and then goes in the opposite direction, not in the same one.
a plane mirror is just like a regular straight mirror
Yeah,
where,
but regular mirrors show you like the inverse of whatever is happening. So it's in the opposite.
uh, sure. But yeah, a plane mirror is really just, it's not going to be like this object distance and this virtual image distance will be the same.
Yeah.
So,
Okay. And then focal length of a mirror is equal to half its radius of curvature. I wasn't sure what that meant. Like radius of curvature, aren't like what mirror is round? It's like what is I don't
so,
is it like of the eye that is C?
so convex and concave, these are spherical mirrors because this would be concave, and then if they overlap, this would be convex.
Mm-hmm.
So these are spherical mirrors, spherical lenses and mirrors and stuff. Yep.
But with the focal length,
Uh-huh.
what is that? Can you explain that one to me, maybe?
Uh-huh. Sorry, I'm just looking for like a good picture. Okay, so okay, so this in the chat here would produce that diverging, or sorry, the concave shape. And this is for the convex shape. And
Oops.
this,
Where did it go? Hold on, I think I lost it.
so so yeah, you could see how the radius of curvature can relate to the focal length here. This particular, so like the first two images I sent were just to show you like how like the concave shape can be and how the convex shape can be, and then the last image shows you like the convex one, and you can see that the radius of curvature is this length from like the end of that circle to the center of the it doesn't seem like perfectly centered, but whatever, center of the circle, and that this focal length here is going to be half of the uh radius of curvature.
Which image are you looking at? Are you looking at this one or the third one that you sent?
Oh yeah, the third one. So that's just the relationship between, like, so that's why they're called spherical mirrors, and that's why they are or spherical lenses, right? And that's where the radius of curvature comes in and how that is related to the focal length.
Okay. So the problem, so you calculate the radius and I don't remember the question. I need to go back and see. It's equal to half. Isn't it half?
Yep.
Is it asking what's not true? Oh, I was confused. I was like, wait, but this looks correct.
Yep.
Okay.
Okay, so
I
diopter.
knew it would be 25. I just didn't know in which direction.
Well, so diopter is like, when you get your glasses, like that's what they measure your prescription in. And
Uh-huh.
so it's called the power in like, this type of physics. So it's 1 over F, but in meters, right? So if we had 4 equals 1 over F, right?
Uh-huh.
We just solve for F, which would be 1 over 4,
Yeah,
which is 0.25 meters, which means it's 25 centimeters.
I understand. So when I got 1/4 and I said that it was a quarter, it was in the wrong unit.
Yeah. So just remember for like power, like diopters, like that's why like your prescription would be a certain type of, like
Yeah,
what.
but
Yep.
my vision's negative 3.75. So
Yep.
that's in centimeters.
No, that's in meters, right?
Oh, I guess that makes sense. So that's how far I can see until it's blurry.
That'll be more so like the 2010 or 2020 or 20 blah 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 vision part, but this is more about the lens itself.
Like the lens in my eye. Like,
No, sorry, the lens of the glasses.
oh,
So because your eye is going to be longer, which means that the light will focus in front of your retina. So to
uh-huh.
fix this, you need a diverging lens for the
A
light rays to divert a bit.
concave lens.
Yep. So that it diverges,
Mhm.
some more, so that when it hits your eye and converges, it'll converge later, and it'll be right at where it's going to be at the retina.
Cool.
So you could even maybe feel in your sunglasses like it getting thinner towards the center.
Yes, actually.
Yep, that's the concave
I
shape.
thought it was just like a curved thing.
So yeah, imagine the concave shape.
Super cool. Yeah, they're like visibly they go in.
Yep. So now,
Wow.
so now you know. So if someone asks you why, right, you're not going to be like, because that's what the prescription says. You're going to be like, well, it's going to be a negative value because it's a diverging lens, and which means it's a concave shape. So, and all that other stuff. So yep.
So if you're um farsighted, is it the opposite? Do you have a converging lens and a convex
Yep.
shape?
And also a shorter eyeball.
Uh-huh. And then it like looks that's why your eyes look bigger in those glasses. Like they look like they're
um yeah, I guess I never really like observed that closely enough, but yeah, that probably makes sense. Um but yep. So yeah, that's
cool.
okay, let's see.
Well then I'm gonna try to go through it myself again now that I understand.
Sure.
Convex lens is used to form. Is this the thing where like you never like see what your eye actually sees? Like your brain like inverts it?
Well, this isn't going into the level of like the brain. Yeah.
Uh-huh. But this is like, it's still a mirrored image. So is your eye the X? Like, why are there two eyes?
Um,
Are they just giving like, where is it supposed to be? Like, if the image is here, you're observing it from the opposite side.
so like at some point I would say to go through in my PDFs folder. I have an optics PDF where I kind of show where I go over the type of images um things can produce. So
Okay.
yeah.
Okay.
Um where's your phone again?
On the couch.
Let me see it.
Sure.
All right, cool. So yeah, basically, if it's diverging, it'll be producing at all times SUV, small upright virtual. And then when it comes to converging, it will depend on the distance of the object. But basically, as the object gets closer, you're going to start off with a tiny inverted real image, followed by a small inverted real image, followed by same size inverted real image, followed by no image, followed by oh sorry,
Virtual.
large, yep, inverted real, and then I mean there's gonna be one where it's no image, and then it'll be large upright virtual. Okay. And so in the PDF you'll see the specific like uh object values and image values. But in general, if as the object gets closer, it'll the image formed will move further away. And since magnification is the ratio of image distance to object distance, as the object distance decreases, the image distance increases and magnification increases. So as you get closer, it gets larger. Okay.
Mhm.
Now, so it's a convex lens. So we need to know that that means it's converging, which means it'll follow the like this.
Mhm.
And the image appears to be upright, right? And
Yes.
that means it can only be this.
Why?
Because if it's upright,
It starts invert. Oh, I understand. So all of these are inverted until it gets to the upright vertical, and since it's up, okay,
virtual, so,
yeah, vert.
yeah, virtual images will be upright. And
Why is it observed from the Y and not the X? Because it's further away, so it can't be like the up close one, or else it would be
so
this.
a virtual image is one that can't be projected. So,
Uh-huh.
like, imagine you have a mirror here, right? And, you know, this is you. And then you look inside the mirror at your reflection. That's called a,
The
vir-
virtual
a
image,
virtual
yes.
image because it's not really a real image, right?
Uh-huh.
Like, let's say you took a laser pointer and you shot it at the mirror and then it bounces off and then it hits the wall behind you. Like, that is a real image because it can be projected and it's
Mhm.
actually causing like photons are actually hitting that,
Okay.
right?
Hope
So
they
that
don't hit.
yeah. Whereas like it doesn't go inside like, the mirror part. So that's why so the image being upright lets us know that it's a virtual image, right? And a virtual image you can't see from the same side of. You can only
Mm-hmm.
see the opposite side. So that's why
Okay.
it's from position Y.
That makes sense.
Yep.
So this is the lens mirror
Yeah, lens.
it's
Yep.
passing through.
Mhm.
Okay. like 36. 12 over 36. Is
Uh,
this how I got B?
yeah, but you're like just randomly doing stuff with numbers.
Yeah.
So like that, isn't gonna work. So like tell me like how to, actually approach this.
So it's in front of the lens, which means that it's wait. Is this the radius focal length thing where it's like half of the focal,
Well, what are we given?
twice the focal length? What is the magnification?
No, I said what are we given?
We're given the focal length and the distance of the object from the lens.
All right. So what equation should we use?
L D.
I don't know what that is,
I'm
but
trying to
I don't know what L or D is, but
length and distance we have. Oh, that's the same thing. Hold on.
yeah. Uh-huh.
Wait, but we just have two lengths. I
So
don't know the
question,
equation.
yeah. Wait, so what you can't think of an equation?
No, I'm not sure for this one.
So what equation has focal point in it? And what equation has object distance in it?
I'm not sure.
Okay, so 1 over F is equal to 1 over image distance plus 1 over object distance. So you def got to get on that equation stuff because this is like a very, very fundamental equation.
Okay.
Uh,
So 1 over
we went
30.
we went over it before too, yeah.
1 over 36 plus 1 over 12 is
So why
4 over 36.
um I
Oh, wait, no, it's not. Hold on. That's not what we're doing. Because F is focal.
yeah,
So 1 over 12 is equal to minus 1 over 36.
yeah.
3. So it's 2 over 36.
Yeah.
Or over 18 is equal to the image.
Yeah. Oh, what'd you
One I.
sorry, what'd you get?
1 over 18.
So what's image distance?
1 over 18.
Well, what's
Object distance is 36 centimeters.
okay. So what's image distance?
1 over 18.
Nope.
What do you mean?
Look at what you calculated for. What did you write in your math equal to?
1F minus. So image distance is 18.
It's 18. Yeah, you're saying 1 over
Well,
8.
yeah, that's what I'm saying. I'm saying 1 over image distance is 1 over 18. That's how I have it written down.
Yeah, yeah. But the image
I
distance
know.
18 part.
Yeah. I know, I know.
Yeah. So the image distance is the 18 part.
Yes.
So now the magnification formula, which you also need to know, is negative image distance over object.
So it's negative 18 over 36 is equal to negative 1/2.
Yep.
So I just need to memorize this formula.
Yeah, you want to also like know what you're doing, like have a plan for what you're doing. So
Didn't like
what's up?
I mean I'm going through the equations like one that we go over together, like this that we've gone over this week, and that Anki is showing me, but they didn't show me like all of the equations in the 4 or 5 hours that I studied today. So this one I didn't see today.
Okay. But yeah, you definitely want to, because
I know this is like really where physics is struggling, where like if I see numbers, I just throw them together and then I get things like
yeah, you gotta not
I know, 100%.
because even if you get something right, if you guess, like if you
It
don't,
won't be right next time.
yeah. So you want to have a plan of how to
Yes.
approach something. You don't want to just randomly do stuff.
Mhm.
We went over this when we did a problem before with from the section bank. So yeah, you definitely want to like, you know, write it down and make sure you know it because it's like it's a really important one. And like,
Okay.
it's not going to take too long to remember the formulas. So you don't want to lose points from not knowing a formula because that's an easy fix, right?
Yeah.
Okay.
I just Okay, hold on. I know I
Mhm.
did things here. So the work done is subtracted from 89 because or maybe I just did 89 minus 75.
So, okay,
Yeah.
let's think about this, right? So,
Like yeah, the gas like while it's compressed,
okay,
so the like work is happening and it loses like thermal energy.
okay.
So the internal energy would be at a loss because, right?
So
Yeah.
this type of thermodynamics thing, so we consider something called the system and the surroundings.
Uh-huh.
And if work is being done on, wait, okay.
On the gas, like then when it's compressed, the work gets done.
So,
So
uh,
it's like a spring.
so if we're doing work on the system, meaning the surroundings is doing work on the system, it would be, let's make it a positive W. And if the work is doing, sorry, if the system is doing work on the surroundings, let's have that be,
Negative W.
yep.
But
And
it's not being done on the surroundings, it's being done on the system, right? So we have a positive W.
I'm just explaining like,
Oh, okay.
so now if um like heat energy is being done on the system, we can say that that's a positive Q. But if the system releases heat energy to the surroundings, that'll be a negative Q. And the overall energy would be, I guess we can say U is, I mean, I like to have it as W plus Q.
Uh-huh.
They mentioned like Q minus W, but either way should work. Um, so it's okay.
So W is positive and Q is negative here because it's being done on the system.
Yep. So then this turns out to be,
So 75 minus 89, which gives us negative 14.
yep. Oh yeah, sorry, this should be delta. So it
Yeah.
changes by losing 14. Good. So yeah, remember this over here.
Delta U W plus. Let me take a screenshot.
Yep. Good.
I just couldn't imagine it would be anything other than a thermal reaction. That being said, I know this is isobaric chamber, which is like something they do. It's like negative pressure or something, or pressurized. I don't remember. It's something completely unrelated to temperature. And then volumetric. I don't know what this one is. Adiabatic.
What does the ISO part mean?
Um, constant.
Uh-huh. So like same, right? So
Yes.
like isobaric, same pressure, isothermal, same temperature, iso volumetric, same.
Same volume.
Yeah.
There could be like a so
Uh-huh.
oh, so baric is pressure.
Mm-hmm.
Okay.
Yeah, same pressure. So yeah, and then adiabatic is in which
Different.
there's no heat, like okay, heat or mass cannot leave the system.
Okay.
Yep.
Yeah. But I mean, this one I knew was isothermal. I just wanted to ask you what like the other ones were.
Yeah, so tell me why it's isothermal.
Well, thermal, it's like water has a constant like boiling temperature. It doesn't change under any circumstances, like volume or pressure, like it, you know, it always boils at 100 degrees Celsius.
Yeah, so they're talking about the boiling process, and remember that was like the flat line part,
Uh-huh.
like that kind of thing.
Yeah, I know what you're talking about.
Good job.
Yes. Cool.
Okay.
This is a unit thing, probably.
So 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 let's say we had like a distance versus time graph.
Yeah.
Um, what would the slope be representing?
Volume, velocity,
All right, tell me why or how.
or acceleration is distance over time. Same thing. No, not, but
So 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 tell me how you're
no,
getting.
velocity is equal to distance over time. So the distance that passes is directly proportional to the time that passes.
So I'm just saying so how do you get that? Like how do you get that from a graph like this?
Well, because it's a linear graph. So when it's linear, it's directly proportional.
No, so I'm saying like how do you get that in the first place?
Oh, like how you do you get slope?
Yes. So the slope of a distance versus time graph is velocity, right? Slope is
Yeah.
change in y over change in x. So, d over t gives you the velocity, right?
Yes.
So, okay, now if we had a velocity versus time graph or whatever, the
They're
slope.
inversely proportional, so it shouldn't be linear.
So don't worry about like that part right now, but
Yeah,
we're
but it's distance.
so wait, so you're kind of saying just random stuff, but so
No, I'm not. So velocity and time, you multiply time
you don't even know.
times velocity, so it's distance.
Yeah, but you don't even know what I'm gonna ask.
Okay.
So I'm just saying, okay, we have a velocity versus time graph, right? What would the
Yeah,
slope of that be then?
distance.
Well, like,
1 over d.
um, so you're kind of just saying a bunch of random stuff. So if you go back here, right,
Yes.
the slope was the velocity, right?
Yes.
Now here, what would the slope be?
Change in time over change in velocity.
Wait, so then y over here,
Change in velocity. No, yeah, change in time over change in velocity.
but here y wasn't velocity change in time over change in distance.
Oh, it's change in y, so it's v over t.
Okay. And that is equal to acceleration, right?
Yes.
So that's how you get it.
Uh,
Now, if you did the area underneath, right?
mhm.
AKA, you multiply like v times t, right? What would you get? And it's kind of like, so you took calculus recently. So like the derivative is the slope, right? And the opposite of the derivative is the integral, which is the area underneath the line or the curve.
Mhm.
That you can get by multiplying. So like, the velocity part, which is like, let's say, this v, this like I'll use green here. Like this part is the v, and then this part is the t. So to find the area of this, we would just multiply v times t, which would give us
Divided by 2.
uh so just v times oh, I see what you're saying, divided by 2 because of this. Yeah.
Yeah.
But just in terms of like v times t, what would v times t give you?
Distance.
Perfect. Exactly. Perfect, perfect, perfect. Now, here in this question, they're asking about the work, and I know that you have work as FD or FD cosine theta, but there's also a way of expressing it as PV.
I think you wrote that yesterday.
So how can we find the work in this graph here?
Work is this triangle. Like that would be like the area.
Yep, the area underneath this line, right?
Yeah, so it's
Yep.
6 and 3.
Okay, yeah, 3 and then 6. So what would that?
18.
Uh-huh. Divided by the 2, right?
All right, yes, okay. So 9.
Oh yeah. We're talking about 8. Um and then what can we do? So we can also add this rectangle. So 4 by 3, so 12 here.
Mm-hmm.
Now,
But
yeah.
if the graph is just going here, why are we adding the 4 and
Oh, because it's the area underneath.
but why is this square included? Like I thought it was just the triangle.
Well, it's the area underneath.
Okay, I understand because it's not at 0.
What do you mean not
There's
there?
like if this said 0, then it would just be the triangle. But since there's more, like even though it's not part of the graph, like we include this rectangle.
Yeah, so it's the area
Okay.
underneath and the rectangle's underneath.
All right.
Keep that. Yep.
And that's 21.
So
But
now,
no,
yeah.
unit wise, you have to take consideration the 10 to the 5th
Yep. So
and the 3rd.
yeah. So I'll just write it out. So it'll be like 6, like 1/2 of like whatever base times height. So like the base part
Right.
is going to be 6 E 5
T.
pascals times
Uh-huh.
the 3 cubic centimeters
Uh-huh.
plus the rectangle. So that's going to be 4e5 pascals times 3 just 3 cubic centimeters. Right.
Mm-hmm.
Now, do you remember that 1 pascal is equal to, do you remember this? Something over something,
You said this yesterday, right?
maybe?
Was it the ATM thing?
Uh, Kinda. So it's gonna be,
The 700 hertz, or
wait, you're talking
that's
about
different.
frequency now? So,
Yeah,
so pressure is force over area,
yes.
and Pascal is a measure of pressure. So it'll be a unit of force, which is
Force is in newtons.
and then
Sorry, I was looking for the thing. I can't find it, but force is newtons.
yep, good. And then it's over area, which would be in
Uh, meters.
so so what's area? Like how many dimensions?
2. So, but it's not squared because that would be like if it's a square and there. I
Um
guess, yeah, we can do like meters squared.
well, yeah, it's not something that we're just gonna do, but we would have to do it that way because if something is in 2 dimensions, right, that
Mm-hmm.
means that it'll have to be square. Like if you look at an apartment, you look at square footage, right?
Mm-hmm.
Like they're not gonna just give you in feet, because if it's in just like feet, it's in 1 dimension, it's a length.
Mm-hmm.
But if you have 2 dimensions, it'll be a square, right?
Okay. Yeah, that makes sense.
And 3 dimensions would be cubed, right?
Oh, yeah. Okay.
So this will be meters squared.
Mm-hmm.
So now we can plug that in for pascals, but we gotta turn this cubic centimeter into cubic meter so the meters, can cancel.
Mm-hmm.
So from yesterday, I think I wrote like a value to memorize, but it's gonna be like this. It's like one.
The 1 e⁶ centimeters cubed.
Yep. So
6. Yeah.
you could say that, uh, yeah. So that 1 cubic centimeter is 1 e⁻⁶ cubic meter,
Mm-hmm.
right? So now we can do this again. So 6e5, 3e⁻⁶ plus 4e5 times I guess
3 e⁻⁶.
yep. And then I guess we can get, well, 2 goes into this 3 times, and then this would be 9e5 plus -6, -1, plus then this one would be 12e⁻1. So this is going to be 21
E
e
to the -1.
1, which is moving the decimal point to the left once, 2.1.
Makes sense.
Yep. So you saw,
Calculate it, and then you substitute in the exponent.
Yeah, so first of all here, we want to see that the axes, because I kind of glossed over this the first time, but the y-axis is pressure and the
Mm-hmm.
x-axis is volume.
Mm-hmm.
So the only, and we would have to also know that work could be equal to pressure times volume. So since it's pressure times volume, we know that we have to do the area underneath the curve, or underneath the line. And we did that with like the triangle and then with the rectangle underneath. And then it became something where we had to plug in the units. So pascals, cubic centimeters, which then meant that we have to know that a pascal is a Newton per square meter.
Mm-hmm.
And then we have to do that other step of converting the cubic centimeters into the cubic meters. And then we plugged it all in and did it. So there's a lot of steps going on here. So just remember this conversion factor, because that gets really annoying to do yourself. So I would just definitely remember that. Um, remember these kind of relationships, right? Like if you take the slope of something, it'll turn into something in some cases. And then if you want to turn it back into something, like for instance, the VT curve, slope of it would give you acceleration, but if you do the integral, or the area underneath, you'll go back to the original thing, which was distance.
Mm-hmm.
So that's how we know, like the difference between the slope and the area. So yeah, this covered a lot of stuff. So, and you,
Yeah, this is a cool problem.
yep. So
Okay.
yeah.
All right. So, I mean, this, yeah,
Mhm.
sounds good.
Awesome.
Okay. Are we?
Okay.
Oh, yeah, shoot, we went 10 minutes over.
Yep, that's fine. So tomorrow, 2:30 Eastern.
Yes, if that's okay with you.
Yep, yep. And
Cool.
yeah, I would just say continue like reviewing. Like, have you been like reviewing like the questions and that, like the ones that we just did?
Yeah, I mean, not the ones that we've gone over together, but like I make notes of the topic that it covers, and then like if you tell me specifically like you should look at this to answer it, I write it down in my notepad and then I like find it in the drive and whatever.
Yeah, so you can like look at the next the next ones, and then
Hmm.
read the solution. If the solution makes sense, you're good. If it doesn't, we can go over it. And then I would, yeah, continue with the
I
quick.
feel like at the end there were a lot that I got wrong, and then there were two that I was just like so confused with that I just didn't answer them.
Got it. Got it.
So
So yeah,
don't know, like this like end stretch, I would actually feel like we should go over like maybe tomorrow if like I'm sure we're gonna finish it tomorrow. There's not so many left.
yep, yep. Yeah. So yeah, continue reviewing that. Continue doing the essential equations deck. Um, and
Yeah. We also get the Calendly that
measure.
we might have. I
Yeah,
need
and
it.
do the memorize the functional groups as well. And
Mhm.
should be in a good position then. So, all right.
Sounds good.
Awesome. So I will
Okay.
see you tomorrow, and yeah, keep up the good work, okay?
Thank you. All right. Bye, Shane.